Solving quadratic equations. In this video, we're going to start talking about complex numbers. With me, Catherine. So what is a complex number? Well, here's a definition you're going to find in just about any book, but let me break it down for you. A complex number looks like this, a plus bi. A and b are real numbers. A is actually the real number part of the complex number, and bi is called the imaginary part of the complex number. So a complex number has two pieces, a real number and the imaginary number. How I remember the imaginary number, it's the number with the I hooked to it. The other thing we have to remember is that every answer we get has to look like this, a plus bi. The first thing we're going to do is add and subtract complex numbers. Let's look at the first one. When I'm adding two complex numbers, what I have to do is add the real numbers together, a plus c, and then add the complex numbers together, and that will give me my answer. Let me show you an example. The first thing we're going to do is add the real numbers together, 6 plus 8, and then we add the complex numbers together, 3i plus 4i. The answer then will be 14 plus 7i. It works the same thing for subtraction. We're going to put the real numbers together, but this time we're going to subtract. And then we're going to put the imaginary numbers together and we're going to subtract those. Let's look at an example. Just like we did for addition, we're going to subtract the real numbers, 8 minus 5. And then we're going to subtract the imaginary numbers, 9i minus 7i. 8 minus 5i is 3. 9i minus 7i is 2i. Now I want to point out something to you. Let's look at the first example. You're going to notice the answer has a plus sign. But in the second example where we're subtracting, we also have a plus sign. The sign between the real number and the imaginary number depends on when we add or subtract the imaginary number. Let's look at a couple more. We're subtracting the two complex numbers. So the first thing we're going to do is subtract the real numbers, and then we're going to subtract the imaginary numbers. 11 minus 4 is 7, and 12 minus 6i is a positive 6i. That's why we have 7 plus 6i, and we don't have a subtraction between them. Let's look at another one. Once again, we're subtracting complex numbers. So we're going to take negative 2 minus negative 1. Those are our real numbers. And then we're going to subtract the imaginary numbers, 8i minus 7i. Negative 2 minus negative 1 is negative 1. 8 minus 7 is 1. So that's how we end up with negative 1 plus I. Hopefully you can see that it doesn't matter if we add or subtract the complex numbers. The final answer depends on how we add or subtract the imaginary numbers. Let's look at this one. The first thing I want to point out is that negative 2 minus 6i. Well, that's the same thing as saying negative 2 plus negative 6i. So our real numbers are negative 6 plus negative 2, and then our imaginary numbers are 2i plus negative 6i. Negative 6 plus negative 2 is negative 8. 2i plus negative 6i is minus 4i. I'm going to point to it one more time, but remember it's negative 4i because 2i plus negative 6i is a negative. What about this one? Well, we're going to do the same thing. We're going to rewrite 8 minus 4i as 8 plus negative 4i. We're going to subtract the real numbers, so negative 2 minus 8. We're going to subtract the imaginary numbers, 12i minus negative 4i. That means our answer is going to be negative 10 plus 16i. Once again, subtracting the complex numbers has nothing to do with the answer because 12i minus a negative 4i is positive 16i. Here's your turn to practice. Pause the video, simplify, and press play to check. All right, let's see how you did. For A, we're going to add the real numbers together, 2 plus negative 4, and then we're going to add the imaginary numbers together, 5i plus 7i. That's going to give us negative 2 plus 12i. And we know that this is the correct answer because it's in the form a plus bi. Let's look at B. Once again, we're adding the real numbers together, and the imaginary numbers together. So hopefully you get -3 plus 7i. Let's look at C. For this one, we're subtracting. So we're going to subtract the real numbers and the imaginary numbers. Hopefully you remember 8 minus 4i needs to be rewritten as 8 plus -4i. That's going to give us an answer of -7 plus 7i. For D, we're doing the same thing. We're subtracting the real numbers and subtracting the imaginary numbers. This gives us an answer of 7 plus 2i. I hope E wasn't too tricky. We're still adding the real numbers, 0 plus 3. 3 minus 5i should be rewritten as 3 plus -5i. That'll give us 2i plus -5i, for an answer of 3 minus 3i. And then the last one, F, we're still subtracting. 14 minus 15i is the same thing as 14 plus -15i. That'll give us the answer -5 plus 14i. Let's look at multiplication. The rules for multiplication haven't changed. So 5 times -6 plus 3i, we're just going to distribute. 5 times -6, then 5 times 3i, it's going to give us -30 plus 15i. That's a good answer because it's in the form a plus bi. Let's look at the second one. -8i times 3 minus -8i times 2i. Two negatives make a positive, so now we have -24i plus 16i squared. Hopefully you're getting used to every time you see I squared, you're going to put in a -1. So that's what I did. Now we have -24i minus 16. But we have a problem here because it's not in the form a plus bi. So all I did was flip-flopped. -16 minus 24i, that's our answer. If you guessed we're going to FOIL for the last one, you are correct. We're going to multiply the first, outside, inside, and last. Now let's simplify. We're going to end up with 3 minus 4i minus 6i plus I squared plus 8i squared. What I like to do first is collect like terms. -4i minus 6i is -10i. The next step is to substitute -1 in for I squared. This is going to give us 3 minus 10i minus 8. You don't have to, but I like putting like terms next to each other. So I just rewrote it as 3 minus 8 minus 10i, which gives us -5 minus 10i. This is a perfect answer because it's in the form a plus bi. Let's look at a division. When we look at this one, we're going to look at the denominator first. We have to remember that I is the same thing as the square root of -1. And if you remember when we talked about radicals, we can't have a root in the denominator. We can't have a square root or a cube root or anything. And if you also remember, what we did is multiply by its conjugate, which is exactly what we're going to do today. What I did was just take 2 times 3 plus 5i over 3 minus 5i times 3 plus 5i. Doing a little simplifying, that means the distributive property and FOILing, we end up with 6 plus 10i over 9 plus 15i minus 15i minus 25i squared. Let's collect some like terms. 6 plus 10i are not like terms, so they stay the same. 15i minus 15i is 0. So that's how I ended up with 9 minus 25i squared. Yeah, we need to substitute -1 in for I squared. So that's going to give us 6 plus 10i over 9 plus 25. Let's simplify again. That's going to give us 6 plus 10i over 34. But this isn't our answer because it's not in the form a plus bi. And that is actually super easy. All you do is rewrite 6 plus 10i over 34 as the denominator. Okay, maybe I said that wrong. It's just going to be 6 over 34 plus 10i over 34. But we still have a problem because way back 100 years ago, we learned that we always have to reduce fractions. So 6 divided by 34 reduces to 3 over 17, and 10i over 34 reduces to 5i over 17. For me, I think this is a good answer because it is in the form a plus bi. But some instructors want you to write it so that I is on the end, like this one, 3 over 17 plus 5 over 17i. And that is the answer. Let's look at another one. Once again, I is the square root of negative 1. We don't care about the top or the numerator, just the denominator. So we're going to multiply by its conjugate, 2 minus I. We're going to FOIL, which gives us 16 minus 8i minus 2i plus I squared over 4 minus I plus I minus I squared. Let's collect like terms. This gives us 16 minus 10i plus I squared over 4 minus I squared. Yeah, we need to substitute negative 1 in for I squared. So let's simplify again. That's going to give us 16 minus 1 minus 10i over 5. I wrote 16 minus 1 minus 10i because I like to put like terms next to each other. And 4 minus negative 1 is 5. That's going to give us 15 minus 10i. We're not done because remember, we have to write it in the form a plus bi. That's going to give us 15 over 5 minus 10i over 5. And just like the last one, we have to reduce fractions if we can. 15 over 5 is 3 minus 10i divided by 5 is 2i. And that's our answer. Here's one for you to try. You're going to pause the video, simplify, and then press play to check. Hopefully you remember I is the same thing as the square root of negative 1. So we need to multiply by its conjugate, 1 plus 4i. When we rewrite it, we notice we're going to have to FOIL. So the top is going to be 5 plus 20i plus 3i plus 12i squared. And the bottom, or denominator, is going to be 1 minus 4i plus 4i minus 16i squared. Let's collect like terms. 20i plus 3i gives us our 23i. Negative 4i plus 4i is 0. So that's how I get 5 plus 23i plus 12i squared over 1 minus 16i squared. I squared is negative 1, so I substituted that in. And simplify. I like to put like terms next to each other, so on the top I have 5 minus 12 plus 23i. And on the bottom I have 1 plus 16, because 1 minus 16 times negative 1 is 1 plus 16, which is negative 7 plus 23i over 17. But we're not done yet, right? Because it has to be in the form a plus bi. And all we have to do is write everything over 17. I keep saying that wrong, but I think you know what I'm saying. So we're going to have negative 7 over 17 plus 23 over 17i. And that's our answer. It is self-quiz time. You're going to pause the video, do these 4 problems, and then press play to check. All right, let's see how you did. So for number 1, we're adding these complex numbers. We're going to add the real numbers and the imaginary numbers. Hopefully you get 5 minus 4i. For number 2, we're subtracting. And we end up with 0 minus 20i. This is in the form a plus bi. But some instructors will leave it as negative 20i. For number 3, we're actually FOILing. So we're going to do first, outside, inside, last. And then I'm going to simplify. Negative 3 times 2 is negative 6. 15i plus 12i is 27i. And then we have minus 30i squared. I squared is negative 1. So let's put that in there. We're going to simplify. I like to put like terms next to each other. So now I have negative 6 plus 30 plus 27i. Negative 6 plus 30 is 24. So the final answer is 24 plus 27i. And that's good because it's in the form a plus bi. For number 4, we have to multiply by its conjugate, 3 plus 2i. That means we have to FOIL the top and the bottom. This is going to give us 6 plus 4i plus 3i plus 2i squared over 9 plus 6i minus 4i squared. I collected like terms and then put negative 1 in for I. This is 6 plus 7i plus 2 times negative 1 over 9 minus 4 times negative 1. I did a bunch of simplifying here. 6 minus 2 is 4 plus 7i. 9 minus 4 times negative 1 is actually 9 plus 4, which is 13. But We don't have the answer yet because it's not in the form a plus bi. So all we do is rewrite the denominator under both of the numbers. Maybe that's better. Anyway, we end up with 4 over 13 plus 7 over 13i. Thanks for watching. If you liked it, pin me to Pinterest. Remember, you can't get good at this unless you practice, practice, practice. And make sure to subscribe because you don't want to miss another episode. Thanks for watching, and we'll see you in the next video.